Hi, this is T3, day number 7, average values. We're going to start with something really simple. We want to find the average value of these numbers that are given 1, 2, 5, 9, 12, and 13. And just as we learned in grade school, in order to find that average, we're going to take 1 plus 2 plus 5 plus 9 plus 12 plus 15 and divide by 1, 2, 3, 4, 5, 6. And that gives us an average value of 7. Easy enough. Suppose you go 100 miles in 2 hours. Find your average value, average velocity. Well, if I've gone 100 miles in 2 hours, I'm going to take that 100 miles and divide by the 2 hours. That is, I'm going to take my net distance and I'm going to divide by the change in time, and I'm going to get that I went 50 miles per hour. Well, this is our key piece of information, that we're going to take our net distance and divide by our change in time. Well, if I'm given a velocity equation, v of t equals t squared plus 1 feet per second, to find the average velocity from t equals 0 to t equals 5, my average velocity is going to equal the net distance divided by the change in time, just as we just had right up above. Well, my net distance, remember, if I have a velocity equation, I can find the distance traveled by that area between the curve and the x-axis, which we write as the integral of our t squared plus 1, of our velocity equation, dt, from 0 to 5. If I want to find it, the average velocity from 0 to 5, I'm going to look at my distance, my integral from 0 to 5, and then I'm going to divide by the delta t, the change in time, well, 5 minus 0. And in order to evaluate that, I'm going to use yesterday's calculator program, so second Calc 7 or the Math 9, and I'm going to evaluate this integral and get 46 2/3 divided by 5 gives me 9 1/3 feet per second. So when I evaluate this integral, I get feet, because it's the area between the curve and the x-axis, gives me from a velocity equation, gives me back distance in feet, and this change in time is in seconds. So encapsulating what I have right there, we get, in general, our average velocity of f at x is equal to this 1 over b minus a times the integral of f of x dx from a to b. We could also write that as our integral from a to b of f of x dx over b minus a, which is the way we have it written above, with the delta t on the bottom. So to remember that this integral from a to b of f of x dx is our net distance. Not our total distance traveled, but our net distance. Where did I end up at the end of my trip? And b minus a is the delta t. To look at this graphically, if I have this graph, the parabola v of t equals t squared plus 1, if I want the average velocity, here's my equation from above, the average velocity multiplied each side by this b minus a is equal to the value of the integral. So all I did was I multiplied each side by this b minus a to get the average velocity times b minus a is equal to the integral. Well, if I rewrite this, this average velocity is the height of the rectangle. The base of the rectangle is b minus a, and that's equivalent to this, the value of the integral. So if I take everything that is shaded in with these vertical lines, but I move this green space over here, it fills in this pink area. So instead of looking at this shape that I can't evaluate geometrically, I'm looking at a rectangle, which I can very easily get the shape or the area of that. So the average value of function is equal to the height of the rectangle, whose area is equal to the area underneath the curve. So we're just thinking about taking this space, filling in here, and making a horizontal line, which is going to be the average velocity. Sometimes we're going to just eyeball that in and say, oh, about where does it look like that should fit? And other times we're going to be able to evaluate an integral and actually draw it in at a specific height. If I want to find the average velocity of this function, and I'm not given an equation, but it's a nice geometric shape, I'm going to need my net distance. Again, same thing, net distance divided by my delta t, nothing new here. So the net distance is the area between the graph and the x-axis. And I can see that my delta t is 4 minus 0 is 4. Well, the area between this function and the x-axis is a trapezoid, so I can get that as an area. I'm going to look at this length is 4. This length going from 1 to 3 is 2. And my overall height is 3. So I'm going to take the 2 and the 4 and average them. So 2 plus 4 over 2 times my height, which is 3, divided by this 4. So I get a 6 divided by 2 is 3 times 3 over 4 is 9/4 or 2 1/4. Well, if I draw in a horizontal line at a height of 2 1/4,